For this last video of section 2.3 classwork, I want to remind you that back in the first section of Unit 2, we looked at the graph of 2 to the x. And here is that graph. When we plug 0 in, we get 1, regardless of the base. When we plug 1 in, we get the base number, which is 2 in this case. Now I want to remind you that we had just looked at the graph of 1/2 to the x. And anything to the 0 power is 1, so we have that y-intercept of 1. But this time, when I plug in -1, I make that 1/2 have its fraction flip to 2 over 1, which is 2. And then I can plot the point -1, 2, where before with the graph we were looking at in 2, 1, +1 gave me 2. And in fact, if you look at the table in 2 to the x and in 1/2 to the x, you should notice that the negative x's switched their y values with the positive x's. And this brings us to something interesting. And that's where you have the something extra to notice. And I'm going to go to the answers and talk about what is the something extra to notice. When I have a negative exponent, that means flip the fraction, or move whatever I have that has the negative exponent to the other side of the fraction, and now it has the positive version of that exponent. So 2 to the negative x is the same thing as 1 over 2 to the positive x, which is the same thing as 1/2 to the power of x, because that numerator is 1 is going to be 1 no matter how many times you multiply by 1. And what this implies is that those exponential growth and decay functions, when you're looking at, for example, 2 to the x and 1 over 2 to the x, it looks like they are the same graph but reflected over the y-axis. So this brings us to a truth, and I want to remind you of something you've found in the past. In the past, when you're multiplying the function by a negative number, you flip that graph over the x-axis. And I look at that as being similar to a gymnast rotating around a high bar. So that high bar is like the x-axis, it's horizontal. And if I asked you to graph, let me draw. If I asked you to graph two functions, one of them was y equals x squared. Let me actually color code this. And the other one is y equals negative x squared. And I'm just going to do a quick draw. If it's y equals x squared, you have your right side up parabola. If you multiply by this -1, that flips it over the horizontal x-axis, and then the graph is upside down. I'm going to show you with another function. And that's y equals the square root of x. And look at when the square root of x is multiplied by -1, that flips that square root x graph upside down. The square root of x is half of a sideways parabola. This negative sign causes that to flip upside down to be the bottom half. And let me make sure that you're clear, though, that these are two different graphs. So I have the graph of the positive square root of x, and then I'm going to separately draw the graph of negative square root of x, which is just a reflection again over the x-axis. Now, what's new is if the negative multiplication is not outside the function, but inside the function, where x is the number directly multiplied by negative x, then that will give you a reflection over the y-axis instead of the x-axis. And I look at that as similar to a ballerina spinning through, making a pirouette. And you can see that vertical red line here is like the y-axis. And what I'm going to use is the square root of x function to make sure to clarify that difference. And then I have it down here in the examples as well. If I look at the graph of the square root of x, and then I look at y equals the square root of negative x, that's going to reflect this graph over the y-axis instead of the x-axis. So look at the difference of the reflection over the x versus the reflection over the y-axis. I'm also going to separately draw this graph. Now down here, I want you to draw them nicely in a grid so you can see the difference a little bit better, and point out to you that the domain and range of the square root of x is 0 and positive numbers. If I multiply all the y's by -1, then those positive y's become negative y's, and my range changes to being 0 with negative numbers. But if the x is multiplied by -1 before the square root is taken, then if a positive number is plugged in to this x, you're going to get error. Nothing exists right here. So if you look at all these positive x values, you don't see a graph anywhere in that region. If you look at the original square root of x graph, plugging a negative number into the x causes you to try to take the square root of a negative number, and there isn't any real number that does that, so you have nothing over here with that graph. So the negative values of x are first multiplied by -1, and suddenly you have a positive number, and then we take the square root, and we get the values that we would have gotten for those positive x's, but now for those negative x's. So again, it's a reflection over the line. X equals 0, which is the y-axis. And that causes, instead of the range changing, the domain changes. But that's with this particular function. The square root function begins with a domain and a range that are not just negative infinity to positive infinity. Take a good look at it. and through the eyes of this function, understand the difference between when you multiply by a negative number outside the function, you get a reflection over the x-axis, which maybe if you look at this reflection, maybe you can think of it as a vertical reflection, like you've got your hand straight up holding on to that bar, and then somehow you push with your muscles to go and rotate on top of the high bar. You're a gymnast, mind you. So you're hanging on down here, and then your muscles pull you up to be right above it. That's a vertical reflection when negative is multiplied outside the function. When negative is multiplied inside the function, it's a horizontal reflection. And you spin the graph around the y-axis. You could see that as horizontally turning. Now, when you go to the homework has a problem where it's asking you to just take some general looking graph and look at the reflections. Do your best with it. What I'm going to do is I'm going to just kind of draw some random graph. Let's do, so that check mark looking thing. If that check mark represents f of x, then if I want to find out what does f of negative x look like, that will cause it to horizontally turn around the y-axis. And become that. Then if I had instead looked at what happens when I multiply by -1, when I multiply outside the function by a negative, instead of horizontally turning it about the y-axis, I am vertically flipping it over the x-axis. And when I do that, I want to look at it as if I'm holding on to the x-axis like I would if I were a gymnast, holding on to that horizontal bar. And then I am rotating it about that horizontal bar. And negative f of x would look like that. Hopefully that helps, and I'll see you tomorrow.